Good afternoon. Today we are doing our Pre Algebra Packet number 1. You can see in the corner it says it is due on September 26th. If you get it turned in to me by the Friday, September 22nd, I will check over it and see how you're doing and let you know if there's any pages that you need to redo or help you with any of those pages that you're still struggling with. So if you turn it in early by the Friday the 22nd, I can help you redo some of it. So our first page here says Lyra the cat has had an amazing life. Lyra spent the first 1/4 of her years in a seaside cottage. Then Lyra snuck aboard a ship and became the ship's captain for a little while. So she spent some time on a ship. When the ship reached shore, Lyra explored Charleston Harbor for 2 years. A trucker found Lyra and took her with him on many trips across the country. She traveled the trucker for half her life. Now, at the age of 16, so she's 16 years old, Lyra has found a small farm to call home. How long did Lyra live on the ship? So we know she was with the trucker for half her life and she is 16 years old. Half of 16
Your attention,
is
please,
8
with the
years.
owner of an M&M automotive
Then we
courtesy car
have
that
she
is parked
spent
out in front of the
1/4
door.
of her life
Please move it.
in the
We
cottage.
have a
So
the
1/4
owner
of
or
16
driver of an
is
M&M
4
automotive
years.
courtesy car.
So if we know she was
Please move
2
your
years
vehicle.
at Charleston Harbor, 8 years with the trucker, 4 years at the cottage, you should be able to figure out how many years she was on the ship. So when you get word problems like this, just start out by writing down what it is that you know and what can you figure out with what you know, and we're left with just that one question so we can answer it. And it says why my answer makes sense. You can write it out in sentences, or if you did a lot of work like this, you can also just use an arrow to point to the work that you have done. Our next page, oops, finish erasing. So the next page we have, write the numbers 1 through 7 in the circles so that the numbers of each line of connected circles totals 12. So you have 7 numbers. You need to use each number 1 time. And you need to arrange those numbers so each of these lines, when we add up those numbers, they are going to equal 12. So I could start out and say, well, I know that 5 plus 4 is 9 plus 3 is 12. So, okay, so let me see if I can work through another way. I've already used 3, 4, and 5. I cannot use those again. So I could do 3 plus 7 plus 2 equals 12. Okay, so I've got that 7 and 2. 4 plus 7 plus 1 equals 12. I have one number left. 2 plus 1 plus 6. Uh-oh, that only equals 9. So now I have to go back and erase all of them and say, oh, got to start over. Let's think of a new way where I can use all 7 numbers, make each line equal 7, and I don't repeat any numbers. So why your answer makes sense, you're just going to point that arrow going up. You can do it trial by error. There is a way to do it a mathy way. If you write out all the different number combinations that would equal 12 using those 7 numbers, you can figure out how to manipulate it, what number needs to go into that, into the middle circle. But that's just one that you're going to have to work on and do a little trial and error for it. 5-card challenge. Every math packet will have the 5-card challenge. For pre-algebra, we need to make 15 points. I'm going to show you one combination that I've come up with. If we did 9 plus 9 minus 10 plus 3, oh, sorry, minus 3. That's going to equal 5 because 9 plus 9 is 18. 18 minus 10 is 8. 8 minus 3 is 5. So that would count for 1, 2, 3, 4 cards were used. So that is 4 points. Now, I can't use that same thing and just like turn it around and say 9 plus 9 minus 3 minus 10. We're doing the same operations with the same numbers. We can't just shift it around and be doing the same thing. That's not going to count. Even though you get the same answer, you're not really coming up with a new equation. You can use all the operations, parentheses, adding, subtracting, multiplying, dividing. You can only use these numbers one time each in an equation. So you can't use 2 3s in your equation. You can only use the 3 one time in the equation because there's only 1 3 card. So these 5 cards are the numbers that you can use, shifting them around using different operations, and they have to equal the bottom card. Now the challenge is to use all 5 cards to equal that 5. Do you have to come up with that? No. Once you get into algebra and geometry, you have to come up with at least all 5. I already know one of our classmates has found the actual 5-card challenge. Sometimes there's several that will work. So you can try to challenge yourself with that. This equation is worth 4 points. You still have to come up with more equations to equal at least 15 points. You can definitely challenge yourself to equal even more. So every math packet will have different 5-card challenges on it. Our next page is our pattern page. On these pages where we have all class listed, you need to find pre-algebra and do what pre-algebra is supposed to do. Follow those directions. So this is figure 1, figure 2, figure 3, and figure 4. We need to find the pattern so we can continue our table. So in figure 1, we know we have to complete the table. So figure 1 has 1 block. Figure 2 has 3 blocks. Figure 3 has 5 blocks in it. And figure 4 has 7 blocks. Find the pattern, how we're going from 1 to 3 to 5 to 7. So if we look at that, we can say, oh my goodness, we're skip counting by odd numbers. So 1, 3, 5, 7. I know 9 comes next. Continue that pattern on. We do not have to go below. This is for the geometry class. So that is not for us. That is for when those 8th graders in geometry. But we do have a question here. How many blocks will be in the 15th figure? So you can figure out by continuing on and finding figure 11, 12, 13, 14, 15, or you could find the rule of our pattern. It's a little bit easier for this one just to continue that pattern on, and you're going to write the answer on the line that says answer. So for these pattern blocks, sometimes the pattern is really easy. Sometimes it takes a while to figure out our patterns. As the year goes on, we'll get more and more challenging. So now we have a little geometry thrown in, knowing perimeters and area. Remember, perimeter is the outside, adding up all the numbers on the outside. The thing we have to be careful with when we're doing perimeters is making sure that every side has a measurement to it. So we have 2 sides here that don't have measurements, so we need to fill those in before we can do our perimeter. So if we know from here to here was 3 centimeters, we know from here to here would be 3 centimeters. For this one, we know all the way across is 10 centimeters, plus we have a 3 centimeters, 3 centimeters, and a 2 centimeters. So 3 plus 3 plus 2 is 8 centimeters. If we subtract that 8 centimeters from the 2 centimeters, we know this section is 2 centimeters. So now to find your perimeter, you're going to add them all up and put your answer right here. We add centimeters, our answer is just centimeters. So now we have to find our area. In order to find the area of a rectangle, we know it is length times width. When I look at this, I don't see just a rectangle. It's kind of goofy sided. So what you do is you take your goofy sided and you break it into smaller shapes that we can find the area of. So I have 3 different rectangles here. So I know that this is that our length times our width would be 10 times 3. And then for this, the rectangle on top, I know that our length is 2 times 2 plus 3 is 5. So our length is 5 and our width is 3. And then for here, I know my length and my width is 3 times 3. I should be using my dots, not my X's. So you find the area of each of the smaller rectangles, you add those 3 up, and that will give us an area. Please remember that when we are multiplying a centimeter times a centimeter, our answer is going to be centimeter squared. So it's that little 2 exponent of that. All right, our next page. The figure shown is a cube. Answer the questions for your class. Well, it says all classes, so everybody is doing this page. The first thing we have to do is draw a net. A net is when we take that 3-dimensional shape and we kind of open it up and lay it down flat. So if we look at our cube, we're going to cut on its side so that cube will lay down flat, and we have our bottom, and we have 1, 2, 3, 4 sides, and then we have the top. So our net is going to look like this. So that's drawing our net. Now we need to label each side. When it's a cube, it makes our labeling a lot easier because we know we have a side is 8 centimeters, side is 8 centimeters, side is 8. Oh my goodness, all of our sides are 8 centimeters. So it makes it easy to label our measurements because every side is that 8 centimeters. So you need to go through and label every single side with what the correct measurement is. Like I said, the cube is easy, but when we get other shapes, we really have to think through which side is which measurement. So to label each side, you're going to go through and you're going to label all the sides. So make sure you do that. Then our last part is to find the figure's surface area. What that means is every shape that we have to find its area. So on a cube, all of our shapes are the squares. To find that area, we know it's length times width. So we have 8 times 8, my length times my width. 8 times 8 would be 64 centimeters squared. I do that for every square that's in that net. And I can either add up all of those areas. With a cube, it's a little easier because we can say if each one of these is 64 centimeters, and there's 1, 2, 3, 4, 5, 6 that are all 64 centimeters, we could use multiplication. So you can either add them all up or use that multiplication. If we have 6 sides that are 64 centimeters, we're going to write our answer right over here. And remember, your answer is going to be centimeters squared. All right, our next page, we're going to use that same cube, but we're going to do something different with our cube. So let's turn to the next page to see what we're going to do now with our cube. This page, we're going to be talking about volume. So let's walk through what we all have to do. All classes need to do this. The first thing is to write the formula for the volume of a cube. That's length times width times the height. Now we need to show the calculation that you're going to put into your calculator. Well, we have length times width times height. So I'm going to put the numbers in. My length is 8 centimeters, my width is 8 centimeters, and my height is 8 centimeters. So now I can use my calculator and I do 8 times 8 times 8, and I'm going to put that answer right here. And I'm going to remember if I'm multiplying 3 centimeters, my answer is going to be centimeters cubed. Now I need to do the work for pre-algebra. It says, what is the sum of the lengths of the figure's edges? So each line is a length. I need to count up how many of those edges there are, and they are all 8 centimeters. So I can either add up all of those, or I can do my multiplying. I know it's 8 centimeters times how many edges there are. That answer will go right here. Because we are adding up all of our sides, we are staying at centimeters. So it's not centimeters squared or cubed or anything, it's just centimeters. We don't have to worry about doing any of the other work, we just do what is for pre-algebra. Now this page gets a little bit trickier. This is the Goldbach conjecture. Number relationships have intrigued humans for centuries. In 1742, Prussian mathematician Christian Goldbach conjectured. A conjecture is a statement that holds true for all tested situations, but has not been proven for all situations, that every integer greater than 5 could be written as the sum of 3 prime numbers. For example, 34 can be written as 2 plus 3 plus 29, because 2, 3, and 29 are all prime numbers. The only factors of a prime number is the number itself and 1. It can't be broken down into anything else. Like 6, we could say 2 times 3 equals 6. So our factors are more than just 1 and 6. So 6 is not a prime number, but 2, 3, and 29 are. 1 is never a prime number because we can't say 1 is itself and times 1. We're kind of double dipping with the 1 there. So 1 is not a prime number. Prime numbers start with 2. So to this day, so Goldbach's conjecture was later revised to state that all positive even integers greater than 2 can be written as the sum of 2 primes. To this day, Goldbach's conjecture has yet to be proven true for all integers greater than 5, although computer tests have shown a conjecture holds true for integers up through a really big number. Write each number below as the sum of as few primes as possible. In order to do this, we need to know our prime numbers. So we know 2 is a prime, 3 is a prime, 4 is not a prime because we also have 2 as a factor. 5 is a prime, 6, I already explained why that's not a prime. 7, 8 cannot be a prime because 2 times 4. 9 cannot be a prime because of 9 times 9. 10 cannot be a prime because of 2 times 5. Oh, look at that. All even numbers after 2 cannot be a prime because 2 is always a factor of an even number. So we're only going to have odd numbers, and it's not all odd numbers because like we just saw, 9 is not prime, but 11 is. What you're going to want to do is you can do a Google search for prime numbers, and you're going to list all the prime numbers up to 100. So just do a Google search of prime numbers to 100. Then you're going to look to see if you can write each number with as few of the prime numbers adding together to equal that number. So if we look at the number 10, I know 2 plus 3 plus 5 equals 10. That's using 3 primes. Can I find a way to equal 10 using only 2 primes? I could say 3 plus 7. So 3 plus 7 equals 10, and it's only using 2 primes. You're going to do that for each of these numbers. So that's why we need that list of all the prime numbers, so that way we can really know which numbers we can add together to make the number that's there. If you continue to have questions on this one, ask me in class. Mean, median, and mode. We know that to find the mean, when we do mean, median, mode, our first step would be taking all of our data and putting it in order from least to greatest. It's always the first step. Then to find the mean, we add up each number and divide it by how many numbers there are. To find the median, we cross off going to the middle, whichever number's in the middle. And to find the mode, it's which number we see the most of. So we are going to do the pre-algebra section. It does say round decimal answers to the nearest 10th place, which for this page, I'm going to disagree with Mr. Schultz on because we're using money. So money, we round to the 100th. So I rounded my answers to the 100th place because that's how the cents work. But if you've already done it and you rounded to the 10th place, the directions say, I know what those answers should be. Also, we need to look at what we have. First thing I'm going to do is I'm going to look for my smallest amount of things that I bought at the grocery store. So I see I bought stuff for $1.20, 99 cents, 75 cents, and $2.50. So I know 75 cents is my lowest number, and I bought 4 tomatoes for that. So I'm going to put 75 cents 4 times. So I've done that one. Next one would be 99 cents, and there are 2 bananas for 99 cents. Then $1.20, I have 3 oranges for $1.20. And I have 3 loaves of bread for $2.50. So now that I have my data all in chronological order, I can go through and find my mean by adding them all up. We know there are 12 items, so I'm going to divide that sum by 12. That will be my mean. My median, I'm going to work my way in till I can find the middle number. Remember, if you have 2 middle numbers, what you have to do is take that middle number, add those 2 middle numbers together and divide it by 2. If we're able to work our way in and they are, there's just 1 middle number, then that's your median. Now for our mode, we need to see which number is written on here the most times. We do have an answer spot here, but we do not have a question for us, so that is not for us. The questions are for algebra and geometry. We do not need to answer anything on that answer spot. And we have one last page on our packet. This page we will see in all of our packets, just like the 5-card challenge, we will get a polynomial. What you have to do is you have to use these shapes to fill in the big shape. And you can't turn or flip, you can only slide it over. So we need to decide which spot that 1 would go, maybe it'll go here, and which spot our 3 would go. So actually I would do it like that line for 3, maybe it's those 3. And then we have our corner, I don't know, maybe it's that corner. So you're going to use a pencil at first and try to see how you can fit every single figure into the big figure without turning, without breaking it up. If you make a mistake and you go, oh, wait a minute, I'm looking at this and I see this shape right here and I don't have any shape left that would fit in there. Oh, okay, this is why I use a pencil. I'm going to erase that. Okay, I'm going to start over. That's why we don't start off by coloring them in all the way. I like to just draw my lines like this. Some people I know like to color in all the different shapes and make it look pretty. That works awesome too. It's really easy for me to see if you got the answer right when you're coloring it in, and each little figure, each little shape really shows up that way. But if you want to just do the lines, you can do the lines too. There is an answer. You do need to find it to get credit for this page. That is it for our packet pages for packet number 1. If after watching this video you still have questions on a page or two and you want to come ask me, you most certainly can. You can ask me before school. You can ask me during work time in class. You can ask me after school. I am here to help you, but you need to let me know when you are not understanding a page. So come see me, ask a friend how to do it. Do not copy a friend's page because that is not learning. That is cheating yourself out of learning. If you let a friend copy off of you, you are cheating your friend out of learning. So with that, for those of us watching at home, I'm going to say have a wonderful day, and I hope to see you soon. Bye-bye.